All right, here we're still in section 4.2, and I'm going to cover our final example. And in this example, we're going to show how you can use an inverse function in order to determine the range of your original function, okay? So here I have f of x equals 2x plus 1 over x minus 1. So that's a rational function, okay? And it's really easy to determine the domain here. I know I can only use values of x that keep the denominator from zeroing out in this function. So that means the domain would be any number except for an x value of 1. Okay, so that's really easy to reason out. The range, however, it's tough to come up with the range just by looking at the original function's equation. And I don't have the graph of it either to look at, okay? So here's where inverse functions are very useful. Recall that the range of your original function is going to equal the domain of the inverse, okay? So what I'm going to do here is come up with an equation to represent the inverse, and then if I can find its domain, I'll have the range of the original, okay? So to find the inverse of f, I'm going to treat f like y. I'll switch x and y. And then I'm gonna try to solve this for y, okay? And this is kind of a very particular situation that happens. What I'm gonna do is clear the fraction on both sides by multiplying by y minus 1. These will wipe out, and then make sure you distribute here. It's going to lead you to xy minus 1, or I'm sorry, minus x is equal to 2y plus 1, okay? And then remember, the goal here is I want to solve for y. So there's two terms that have y to them. I'm going to get those to the same side. And then anything that doesn't have a y, I'm going to get to the opposite side. So basically, I'm going to be subtracting 2y from both sides as well as adding x to both sides. And that's going to lead me to xy minus 2y equals x plus 1. And then xy subtracted by 2y, those aren't like terms that can really be combined. So what I'm going to do is I'm going to factor the y from both of them like a GCF. Okay, they both have this y in common that I can pull out. And that's very helpful because now I only have a single y rather than two y's in the equation, and I can isolate y by dividing both sides by x minus 2. So I end up with this as my inverse. Okay. So again, I think probably the tricky part on all this is to go from here to here, understand that I factored out y. Okay. All right, so now this result is my inverse. I'll use function notation. And I want to ask myself, so what is the domain of the inverse? It's all real numbers except for 2, right? 2 is the only value that's going to make that denominator turn out to be 0. So from here, I can say the range of my original function is the same thing, with one exception. Now we're talking about range, so we have to say y cannot equal 2. Okay? So very good use of an inverse in order to find the range of an original function when you don't have the graph of that original function in front of you.